Hi, I'm Andy Wang, an AP Statistics student from A Period Congress, and today I'm here to talk a bit about our statistics experiment, which is about distractions when doing work. So let's start off with a bit of background. Students typically spend a lot of their time on homework and studying, but while they do their homework and while they study, there's a lot of distractions. Oftentimes, students listen to music while studying, they can text while studying, they can go on YouTube, they can go on social media, they can play games. These can all be distractions to a student's work. Now, while these distractions are generally thought of to be unhelpful, there are also things that they can do during their work that can be helpful. For example, if they're studying for a physics test or statistics test and they contact their friend to ask questions or study together, that can be helpful to a student's productivity. Likewise, if they ask another student for help with homework, that is generally helpful for a student's productivity. And our goal was to determine whether or not these possible distractions were good or bad to productivity, whether they had a real effect on a student's productivity. Now, to determine the answer of this question, we ran an experiment, and we began our experiment by choosing 3 short questions from the AP Statistics textbook that the students could do. Now, we took one period, A period, and we assigned them to individual work, meaning that they couldn't talk to anybody and that they were just going to do work on these questions alone without any devices, simply with a calculator and the textbook. Now, we took a second AP Statistics period and we gave them devices, we allowed them to talk to each other, and we gave them the same problems to do. And to both of these periods, we gave them a total of 5 minutes to do as many of these 3 questions as they could. And we recorded the number of questions each student in each period completed, and we wanted to compare these 2 distributions to see whether or not they were similar enough to conclude that there was no effect, or to see if these distributions were different enough to conclude there was an effect of these distractions on a student's work. Now, this was our resulting data. As you can see, C period had a slightly larger distribution in the number of problems that were finished between the students, and most students between A period and C period finished 1 problem or 2 problems. Now, there was 1 student in C period who finished all 3, and there were 2 students in C period who finished none, but for A period, all the students either finished 1 problem or 2 problems. Here's a graph of our data, and it's just modeling the data that was previously shown in the slide before. And as you can see, there isn't too much diversity with A period, but with C period, there's a bit more. Now, to actually look at our data and conclude whether or not there was an effect, we had to use the chi-square test for homogeneity, meaning we had to see whether or not these 2 distributions between the periods were similar enough to say, no, there was no effect, or yes, there was an effect, since these are different samples. Now, our null hypothesis was that the 2 periods would have the same distributions of students in the number of problems that they finished, while our alternative hypothesis was that these 2 periods would have different distributions in the number of students and the number of problems that were finished. And we used an alpha level of 0.05 or 5%. Now, before we actually drew any conclusions based on our data, we had to check to make sure that our experiment was really valid and had satisfied all of the conditions for our test. Now, the first condition we had to confirm was the simple random samples test, or whether or not our samples were essentially simple and random. Now, for this experiment, we assumed that each class was a simple random sample of AP Statistics students, and we did this in order to minimize the amount of bias in the experiment. While each period might be slightly different from the other, and A period might be more productive or less productive than C period, we grouped each sample by the period in order to prevent the amount of bias that there'd be if we had students talking and working silently in the same room. There would be a lot of intergroup interference, and there would be a lot of bias and a lot of factors that would be introduced into the experiment. The next condition that we checked was expected counts, and as you can see in this table to the bottom right, expected counts were not all greater than or equal to 5, meaning that we had to proceed with caution when we moved on with the experiment. And the final condition was the large counts condition, which our experiment likewise did not satisfy because we weren't sure if there were more than 160 AP Statistics students who work undistracted on a regular basis and 210 AP Statistics students who work undistracted on a regular basis. And likewise for this condition, we had to proceed with caution. So after checking the conditions, we ran it through the calculations, and here's what it looked like. So we had a degrees of freedom of 3, a chi-squared of 2.877, and a p-value of 0.411. Here's the chi-squared graph to the right, and we can see that there is a relatively high chance of this occurring by chance. The p-value of 0.411 means that there's a 41.1% chance, or 0.411 probability, that we could randomly just get these two distributions if they were the same. So this was not enough evidence to reject the null hypothesis. So in conclusion, our p-value of 0.41 was greater than our alpha value of 0.05, meaning that there is a high probability of getting such distributions by chance if the true distributions were to be the same, and if the null hypothesis were to be true. Therefore, we did not have statistically significant evidence to reject the null hypothesis, and we could not conclude that there was a real difference in the true distributions of the two periods, and a true difference in the distributions between working independently and working with devices and with your peers. Now, there were many sources of bias that might have influenced the results, and we took several steps to minimize the amount that came in the end. First of all, we made sure that all of the students did the assignment in the same condition at the same time in the same classroom to make sure that they were put under the same conditions when they completed the problems. Likewise, made sure that all of the students, regardless of which group they're in, did the same problems in order to reduce the amount of fluctuation that there might be in the difficulty of the problems, which might have skewed the results to one direction. Now, despite this, there are several remaining sources of bias in the experiment. First of all, we only gave them 5 minutes to complete the 3 problems, which might have skewed the results in one direction, made them feel less or more inclined to use devices during their work. Likewise, we did it during a class period, which might have skewed the results. Since class periods are typically allocated for learning, some students might have felt less inclined to take out their device and use it for detrimental purposes like scrolling through Facebook or watching YouTube, which they might be doing at home while they complete their homework assignments. And finally, everybody was in the classroom together, meaning that for C period, who were allowed to talk, if they were going to talk to somebody, they would have talked to students doing the same problems at the same time, which might have made them more inclined to finish more problems. Now, the experiment was inconclusive, possibly due to the large amount of biases that might have remained, or due to the failed condition checks at the beginning. If we were to take more action, or if we wanted to, for example, recommend to students to spend less time talking to their friends or browsing social media or having distractions out while working, then we would need a more extensive survey to determine whether or not the null hypothesis could be rejected. In particular, I'd recommend future experiments to give these students a longer period of time to complete the problems and to give them more problems so that there'd be more diversity in the results, and so that we could model their behavior as they do homework at home a bit better with this experiment. Likewise, I would recommend a larger sample so that it would be more representative of the population, and these things would greatly reduce the amount of bias that there would be in the final results and would probably change the results greatly. Thanks for listening.